Chemical bonding, the Lewis model. In this tutorial, we will be looking at the Lewis model defined, Lewis symbols, examples of Lewis symbols, the octet rule, and helium as an exception to the octet rule. Lewis symbols. The Lewis model can predict whether a particular set of atoms will form a stable molecule and what that molecule may look like. A Lewis symbol consists of a chemical symbol for the element plus a dot for each valence electron. The dots are placed around an element symbol with a maximum of 2 dots per side. Examples of Lewis symbols. The elements of period 2. So lithium has 1 valence electron represented as 1 dot, and that 1 valence electron is represented as 2s1. Beryllium has 2 dots representing 2 valence electrons and 2s2. Boron has 3 valence electrons represented as 3 dots, which are represented as 2s2, representing these 2 dots at the top, and 2p1, representing this 1 dot on the side. Carbon has 4 valence electrons, and I know that this is deviating because you would think, okay, if we were distributing these electrons, we start with 2 together, then we have our third, so why isn't the 4th coming on the bottom? The 4th isn't coming on the bottom because carbon undergoes something known as hybridization, which we will be talking about in the future. So for the sake of this slide right now, I'm going to tell you to distribute the 4 valence electrons as 4 dots, 1 on each side of the carbon symbol. These 4 dots, representing the 4 valence electrons, are represented as 2s2, 2p2 in the electron configuration. Nitrogen has 5 valence electrons, the first 2 being together, 3, 4, 5, representing 2s2, again, these 2 electrons at the top, then 2p3, the 3 electrons found here, here, and here. Oxygen has 6 valence electrons represented as 6 dots, which we can find in the electron configuration as 2s2, 2p4, where the 2 and the 4 are added together to get 6. Fluorine has 7 valence electrons represented in the electron configuration as 2s2, 2p5. And finally, neon has 8 valence electrons represented as 8 dots represented in the electron configuration in the highest principal energy level as 2s2, 2p6, where the 2 and the 6 are added together to get 8. The octet rule. Atoms tend to gain, lose, or share electrons until they are surrounded by 8 valence electrons. An octet of electrons consists of full s and p sublevels. S2p6 is a noble gas configuration. So in neon, we can see the full S2p6 configuration in 2s2, 2p6. In argon, we can see it as 3s2, 3p6. And in krypton, we look for the highest principal energy level, and we can see this as 4s2, 4p6. Helium as an exception to the octet rule. Helium is an exception to the octet rule with the formation of a duet, in other words, 2 electrons. The n equals 1 principal energy level fills with only 2 electrons. This is represented as the electron configuration of 1s2, representing the 2 dots here as the 2 valence electrons. Additional exceptions to the octet rule will be discussed in upcoming tutorials. So what did you learn? We defined the Lewis model, talked about Lewis symbols, examples of Lewis symbols, the octet rule, and helium as an exception to the octet rule. Need more help? Please feel free to contact me. Have a great day.